we build the solutions to kind of like help us to predict the future. But I think we shouldn't be removing the expertise and domain expertise judgment from those tools and from the math. Like they complement each other.
Welcome to Inside the Algorithm, the show that goes beneath the surface of artificial intelligence into the scientific research, technical breakthroughs, and academic thinking shaping where this technology is actually heading. I'm Jeremy Bradley, Chief AI Officer at Datasparq, a leader in transformational data and AI upskilling, career development, and progression. Each episode, I sit down with the researchers, data scientists, and technical experts working at the true frontier of this field to explore not just what's happening in AI, but also the real science and thinking driving it forward. Whether you're building sophisticated AI systems, leading teams through AI transformation, or driven to understand what's really happening beneath the headlines, this is the show for you. In today's episode, we're exploring two rather different angles when it comes to successfully delivering data and AI projects: the mathematics of forecasting in complex networks, and what it actually takes to build and lead a data science team that delivers. My guest is Dr Judit Guimera Busquets, Head of Data Science at Datasparq, where she oversees data science delivery across clients in aviation, logistics, supply chain, and beyond. Her PhD from City University of London focused on developing advanced methods to predict air traffic network growth, building a framework that models not just demand, but also how changes in connectivity across an entire network cascade from one node to the next. That academic foundation has shaped everything that she's done since, from working on some of the most ambitious data science projects to thinking deeply about what separates data science teams that actually deliver from those that don't. In this conversation, we get into the technical architecture of network forecasting, the question of what she would do differently on that same problem today with access to modern AI tools, and her views on what great data science leadership really looks like. I do hope you enjoy it. Very warm welcome, Judit, to the podcast. Thank you ever so much for joining us.
Thanks for having me as well, Jeremy. Pleasure to be here.
I want to crack on with our sort of first question on your research, which was around air traffic forecasting obviously in aviation. So before we get into the detail technically, I'd like, for listeners who maybe haven't thought about this problem before and why it's a problem, can you just set the scene for us? Can you sort of explain what makes forecasting, demand forecasting, I suppose we're talking about here, in a network, different and quite tricky from other problems?
I think when people think about forecasting, they think about like predicting kind of like, sales for a single product or estimating passengers demand for kind of like a isolated standalone route. But in an air transport network, the system is a complex and living system where kind of like everything is connected to everything else. So I think what makes the forecasting within a network, kind of like framework or like setting, different, it comes down to, for example, like the domino effect or kind of like the cascade effect. So like traditional forecasting of a product, where you have like a change of one of the items rarely will break the rest of your kind of like catalog, right? But in air traffic forecasting, a single change of like the network, so like maybe an airport pair connecting where before there wasn't a route there, or like two airports that are connected now, get removed that flight that was available, kind of like cascades through the entire system.
Right.
So that kind of like knock-on effect on everything else is what is one of the challenges and one of the differences between kind of like between like a single product like forecasting or like a single route forecasting than the network itself.
So this isn't then like a sort of standard forecasting problem at all in this respect. If I was trying to forecast how many cars of particular model or manufacturer I was going to sell in the next 6 months, in the next year, and I've been selling that car for absolutely, for many years, then I would just be using, previous sales data, maybe
Correct.
something cyclical, maybe something periodic based on the time of, year, the time of the month, maybe, and then some, because it's quite an expensive purchase, maybe some economic sort of indicators would all sort of go into the mix and go into that forecast approach, and I'd end up with something that was, probably reasonably likely to give me a decent outcome. But what you're saying, I think this is really fascinating in the world of aviation, is that when you go back in time, you look at the sort of previous data, you're not actually looking at the same world as the one you're about to enter. You're looking at a different world because it's differently connected. Is that the
Yeah,
challenge?
your kind of like map of flights or kind of like your schedule is completely different. It kind of like evolves and changes over time. So yeah, so like you can't just say in 10 years time my network is going to look the same as right now, because actually it's not.
The world you looked at when you were writing this thesis, and doing your research, was one. I mean, it was. There was a nice graph in it I saw, which showed it showed the sort of distribution of connectivity, and it shows you, how many links you've got of a particular distance apart, and so it looked like the world of the sort of um, the local hub airline, the sort of cheaper airline, which is doing shorter hops, was very much part of this world, and there weren't proportionately anyway many journeys in that data set which were sort of reflected sort of 2,000, 3,000, 4,000 mile long haul flights. So that's a I mean that how do you account for that kind of network bias, or is it a case of, well, this is the structure of the network we have, this is the model that we're trying to capture from the data?
So the example application that I used was the US transportation system, and it's a mature system. It's a steady state, like, and it's really based on like hub and spoke, as I mentioned before. So like the graph that you are referring to probably is like not degrees, or like how many airports have like really high number of connections, and then the distribution of like, and you could see like a really skew towards the left hand side. So like there is fewer airports that are connected. Um, to a large number of airports, and then there is less that are connected to less. Sorry, there are more that are connected to less, which basically represents the hub and spoke kind of like system and network. So I think the way that I try to represent that was introducing the kind of like network theory metrics, which basically kind of like explain the topology of the network. And again, like they look like this because it was the US and it was like, like a steady state, like mature system. They will probably look like completely different if I was using Brazil, for example, which is
Right.
quite like a young um, air transportation system. And probably they are more like point to point rather than hub and spoke. Or Europe, for example, which kind of like, yes, it's many countries, but within, like it's kind of like operates as a one single kind of like a big aerospace, let's say. So yeah, so that's the way like how I represented the topology and the characteristics of the network.
Okay, so I'm really keen to sort of delve a little bit more into this sort of the network theory element, because I think this makes it quite a both quite a challenging problem, and also one I don't think is particularly well tackled today. So you're looking at the structure of the network. We've already talked about the fact that there is a higher density of shorter hops, of short haul flights, and a lower density of long haul flights. So did you look at sort of characteristics like sort of power law distributions on connectivity, or sort of, there's lots of interesting sort of features that I know sort of network theorists sort of pick out around either power laws or
Yeah, I mean, I
yeah,
think
that kind of thing.
in terms of connectivity, I think the US was like a power law, like follow a power law distribution.
Right.
For this particular case, I looked at, I think it was like four different kind of like variables that define the topology of the network. So like node degree, eigenvector centrality, clustering coefficient, and the weighted node degree kind of thing. In the end, and I used them for the connectivity model. So the connectivity problem was kind of like split into two. So one into kind of like two classification models. So one that will look at link addition. So like when looking at the probability of a link appearing into the network. So and then the other one would be the link removal kind of like model. So like looking at the probability of like a link being removed from the network that existed before. So, and when I talk about links, I talk about like airport pairs.
Yes. So I didn't understand that. So that's really interesting. The problem isn't just one of forecasting in the presence of a network that's previously changed considerably over time. So looking at trying to treat the data in a consistent way over those changes. It's actually looking into the future and go, what's the probability the network changes again? And new links are introduced in 5 years, 2 years, 7 years, whatever it is, or taken out of the network. That's really so. How did you go about coming up with a model for that sort of that dynamic network piece?
Kind of like my modeling framework that I put like forward, kind of like had different kind of like models, let's say, or like steps. So the first one will look at the city pair demand generation. So we'll look at the true origin, true destination passenger demand between cities, independently of like, the routes that they take to go from city A to city B. And that kind of like use socioeconomical variables like population, household income, type of destination, whether it's like leisure, like business destination, and so on. Basic kind of like simple econometric models. The second model was the kind of like that network evolution, connectivity, and itinerary assignment. So in here, what I looked at was how this connectivity changed. So again, like I looked at which links were removed from the network and which links were added into the network. And then by assessing this, or like by like predicting all those changes, then I kind of like will create the new itineraries that will serve those city pairs. And then the second kind of like a step of within that kind of like second stage is the itinerary assignment. So like once I know how the connections have changed, now let me allocate that passenger demand between city pairs across the different itineraries that exist, either non-stop or like one stop. And then the final one, the final stage is kind of like looking at those allocated kind of like passengers volumes aggregated at the segment level. So like, for example, if you got, like someone going from JFK to Chicago and then San Francisco, you will, that volume, that passenger will be in two segments from JFK and Chicago, and then from Chicago and San Francisco. So aggregating those and then translating those into like number of flights and operations, etc. So I think the way this work was kind of like, and again, the other point that I want to say is that the framework that I developed was explicitly kind of like designated for like medium and long-term forecasting, kind of like more serving for like policy evaluation. So like what you mentioned before about like, should we build an airport here or not, or like a second, terminal, runway
Exactly that infrastructure that
in
we're talking
Heathrow, yeah,
about.
infrastructure kind of thing. So kind of like the goal was kind of like capture like that systematic kind of like shifts over a multi-year horizon rather than knowing the granularity, day-to-day granularity of
Who's
like.
going to turn up to the airport tomorrow? Yeah.
Yeah.
Yes.
So I think that's an important aspect. So basically, the way the framework ran was kind of like as a dynamic kind of like feedback loop, or like a simulation, let's say. So at each step, you will predict how many people there will be, or passenger demand across the different city pairs. Then we'll look at the connectivity, how it has changed based on like previous year, and then compile those itineraries available, and then compile the market share of those itineraries, and then compile and then predict the flight frequency. And then you will move on to the next step, which will be the following year, and so on.
Wow. Yes, complex doesn't even come close. What did the data look like for this? I mean, this is obviously publicly available data sets from the US
Yes.
airline market. Is that right? Aviation
Yes,
market.
correct. And that's why, the one of the reasons why I chose the US as
Yes.
a example application, because like you can get a lot of data from it. So yes, like the entirety of my thesis is based on like open source data. from kind of like air traffic volumes and demand, passenger demand, and like what they paid, and as well like from BTS, I think it's called. So this is like from the Bureau of Transport Statistics, but they have as well like information around like population, economic, like household income, average household income, and so on. And so all the information that I took was from available
Yeah.
open sources.
Wow. So capturing the propensity to want to travel, the means to do so, the economic means to do so across. Um, I know somebody who's still trying to find his flights for for a summer holiday. I know it's not exactly cheap, but you really do have to um, engage in the network hunt to get
Yeah.
the best sort. The
And
Go
at
on,
the
yeah.
end of the day, I would say like aviation industry is cyclical and go hands on hand with the economic kind of like cycles as well. So
Yes.
you can always see like it's proven there is a lot of research out there, and that's why like to model or to predict the city pair um, passenger demand usually like with a simple econometric model, it's basically what is used across across all the practitioners and so on.
Partly then forecaster, but partly scenario planner then in that you said yourself, well, naturally an airline or an industry will want to go, what if we all clubbed together and built a new hub airport in the middle of Kentucky or something like that? Would it be a massive you know driver of traffic, or what kind of would it be worth the investment fundamentally?
Yeah, no, totally, totally. I think and like within my framework, like I generated predictions in the long term, in the medium long term, and based as well in based on like different kind of like socioeconomic kind of like levels, so like whether like population or like income or average household income was like increasing like low, medium, or like
Yeah.
high, so that you could see like the differences of that impact as well. So yeah, but you could like I mean, for example, like in the case of like something happening, like a shock event happening, like the pandemic, or like like a closed aerospace because of like geopolitical reasons and things like that, you have that framework, so it's a matter of like pushing the fiction, or like pushing the boundaries of like how you want to test the model and how see it reacts.
Okay, so that's really good. So you mentioned the pandemic, and I'm really keen to come on to this. Obviously, there's something which was completely sort of anticipatable, really, when it did, strike in 2019, 2020. What happens to a model like this, or and how could it be used or repaired, I suppose, in a scenario where you have a change that's so dramatic, that's so catastrophic, really, for well, for that industry, certainly for a few months. What happens to that kind of model? What place would it have in sort of trying to aid a recovery in that situation?
I think yeah, when something like this happens, it's almost like a structural change, right? And I think it completely kind of like breaks the core assumption of the mathematical model, and it kind of like exposes in a way exposes kind of like the mathematical kind of like foundations and limits of the forecasting. I think in a way it breaks the historical correlation, right? Like econometrics and machine learning models, like they are fundamentally built on the premises of like what happened in the past,
Yeah.
and kind of like finding those like correlations between and patterns between variables, no? So like it is proven that like a percentage increase on household income usually translate into a certain raise in passenger demand. But then when something happens like this, like a pandemic, then kind of like basically it just doesn't drive the behavioral kind of like relationship. It just like breaks everything. It snaps like and overnight almost. And again, like I think in the limitation of like, because we are using historical data, at the end of the day, probably this is a situation where the model never s- has never seen kind of like that situation, so it pushes
No.
boundaries
Right.
of the boundary limits, let's say. So I think that's why like going back to what if it's scenario planning, I think that's the way we need to think in practice of
Yes.
like how these frameworks should be used. So it's kind of like it's almost like as well on like the people who are kind of like building those models, and like how can quickly we can react to the context changing, and use those tools that we have regenerated to actually make better decisions when something like this happens. So like use the framework to generate like different kind of like outcomes based on different levels of, I don't know, econometric variables, or even like kind of like a stress testing, like your models of like like extreme situations such as like a pandemic, aerospace closure, and there was the volcano as well, so, for example, like
Yeah.
right, like years ago,
Yeah.
that closed their aerospace as well from one day to another, and so
Yeah.
on.
I remember.
And I think the other aspect as well is probably like keeping a kind of like human in the loop. So I kind of like almost like accepting that, like, yes, we build the solutions to kind of like help us to predict the future, in a way, but I think we shouldn't be removing the expertise and domain expertise judgment from those tools and from the math. Like they complement each other. I think I think ultimately it's not the limit of the any forecasting model, or like, or any kind of like model, etc. It's just assuming that it will do everything without the human context. So I think it's there is always, for me, there should be always like that human expertise, and
Indeed. And I think you hit on two very important principles of modeling, data science modeling, AI modeling, whatever version you're doing in, which was the first was, if the model hasn't seen historically data that it's been trained on that reflects your current scenario, the chances of it, without significant aid and significant intervention, the chances of it being able to produce a forecast which is in any way realistic are pretty much minimal. And I think
the
people for
probability of that
right.
being forecasted is just not, like the your model predicting that this is going to happen is just not, it's not, it's really low.
Exactly, and I think that's very true of any AI model. That if you're asking it to predict or perform a task that's outside of its operational exposure previously, operational parameters, you're asking it to um, approximate wildly, hallucinate, whatever word you choose you choose to use, really. But I mean, that's where it comes from. Is when you're basically saying, we've only trained you on this bit of history, and we're asking you to predict something
Now
that's over
go.
here, that's miles off of your normal understanding.
Yes, totally. And I think when in the past has happened these things, like the economic crisis in the past, usually you would incorporate those, because you don't, either you drop this data and don't use it because it's like, it's not that because it happened 10 years ago it will happen 10 years after, or you use dummy variables that like absorb that change. And I think maybe when I was talking about like human in the loop, is that maybe like you need to think about like when these models are in production, maybe allowing for a like a way in, to the human like adjust when something
Okay.
like big is happening, for
Yeah.
example.
So let's focus on that just briefly then, because I think this is actually quite relevant contemporarily. So the conflict in the Middle East, which just is kicked off in the last sort of couple of months, massive impact on global aviation. I would imagine all those huge hub airports in sort of Middle Eastern countries, from sort of Emirates and the like, and that were certainly very, very significant connectors of global air traffic. So those all had to be routed round, avoided. How would a human in the loop, which I think is the second great principle, by the way, in terms of making sure these systems work effectively, how would a human in the loop then, with a model such as yours, maybe if it's been trained on 2025 data, 2026 data as well, how would they use your setup but manipulate it and be that sort of smart arbiter to enable the model to be able to cope with a situation like that?
I think, like either like allowing to adjust elasticities, or like add introduce like some like custom dummy variables, or even like kind of like plug out some of the connections, like those links don't exist anymore because basically those airports are inoperative,
Yes.
like for a period of time.
Yeah.
And
Gone.
so almost like being able to remove that node, for example. And even sometimes, like even if having that human in the loop might not been, or might not have allowed to make the change so quickly, right? Because things like are a bit uncertain, and like you don't really know when they're gonna, plug the, put the plug, pull the plug, and this is gonna explode, and like it's gonna unfold and so on. But I think if as an expert, or like you're, like you are monitoring what is happening in the world, then like you could already before start running those what if scenarios with those kind of like changes that you think that might happen,
Mm.
and then kind of like a bit, have a bit more notice of like how it
Yes.
could impact.
Yes.
Mm.
And it's not just the impact of the event itself. It's the sort of elastic rebound afterwards, both
Yeah.
from the
Yeah.
pandemic and something like this, of people going, "Oh, thank goodness, now I can do that travel that I've been postponing, and we're all going to do it together." So suddenly, you've got this huge bulge of demand that comes through. I hope you're finding this conversation as fascinating as I am. If you're getting value from the research and technical depth we dig into on Inside the Algorithm, please take a moment to follow the show and leave us a review on Apple Podcasts, Spotify, or YouTube. Every follow helps us reach more of the brilliant minds doing this work and keeping the rigorous, substantive conversations going. You can find Inside the Algorithm on the Data and AI Mastery podcast feed, or watch it on the Cambridge Spark YouTube channel. You will find the links to those in the show notes below. Right, let's get back into it. I'm going to switch tack a little bit, Judith. So really onto your current role. So you're currently head of data science at Datasparq, a professional services company. So you don't just have a team that solves one problem in an organization. You're fortunate enough to look at running multiple concurrent projects across multiple clients, multiple sectors, in fact, as well. So not just in one sector, because you're running a team that works across this diverse set of projects and industries. That the development process for those data scientists, those AI engineers is is going to be really important. I know you have some strong sort of views on this particularly. So what do you think then as the sort of core capabilities and qualities that you would look for in data science, data scientist who's looking to sort of develop themselves and deliver impactfully in this really interesting sort of ecosystem of projects?
It's not just about experimenting and doing research and like building a solution just because like it's interesting. It needs to, like you have to have that mindset of like always thinking of like what is going to impact, and how it's going to, like what it's going to bring to our clients. I think the other point is pragmatism over perfection. Like in academia, you are kind of like chasing that like 0.5% improvement on model accuracy, but actually on a business setting, if you can get within, I don't know, like 3 or 4 weeks, 80% model, and that 80% accuracy model, that it's already running in production, then it's better than a model that might take 6 months to develop and gives you 95% accuracy, but then it's more complex, or like it doesn't really work in production, and so on. So it's always about like thinking that like agile, and think about like what delivers quickly, quick wins, and then you can still develop in parallel, but at least you have something that is giving you value already. And then yeah, like simplicity over complexity. A lot of like all our clients at the end of the day want kind of like and want to understand actually what is like how the predictions work, and it's much easier to add explainability layer into a linear regression model than neural networks and so on. So again, like simplicity. And then I guess like that mindset of like production first, kind of like ready mindset. So like although we might look at like developing a POC or MVP, etc., and it's a bit like more research look like, um, research like we you need to develop the code, and you need to think about like this is going to be in production, so like think about like testing, think about like clean code, modularized code, and so on. So it's not just like a blank canvas and like yeah plugging lines of code across, but yeah, it will help a lot on the kind of like consequent subsequent phases of like productionization and so on.
So have you got any sort of observations from success stories that you've seen previously which enable your data scientists, your engineers to really make that final move? Because I know it's such a challenge for many projects to get into. Right, we've written this thing, we've invested in it, we're using our data brilliantly, and now how do we get the stakeholders to actually use it?
I was mentioning before about like the so what. So I think it's really important to understand like, who are the end users, how are they going to use it, how is this going to be surfaced, and so on. It's if the output is going to be just in a folder where no one can access, then what's the point of doing the solution? Because then no one is going to use it. So it needs to have like that mindset of like actually thinking like you need to start talking to end users like early on, even like at the first week of like when you are trying to see the and also to understand like whether do they actually need this solution, or actually the definition of done, or like what we're trying to predict, even like the definition of like the outcome of the prediction, like what is it, like passenger volumes, or actually is it aircraft number, like different like these aspects. And then I think as well there is an aspect that I see sometimes, which is like how much people can absorb change, or like want to absorb change as well. I think in some of the projects that we have the most success is also like some of the projects where we had kind of like champions within the business, within our
Right,
clients' business,
very good.
and kind of like really believe on like these are solutions that actually could make a difference into their business.
So looking at everything that's happened in sort of data science and AI, and we've sort of alluded to some of it along the conversation, what do you think people need to be sort of really paying attention to in applied data science, in AI now? What do you think is going to have the most impact going forward for you and your team, for the industry as a whole?
I think there is a kind of like a shift towards, I think, like a small, highly specialized models, for example. So rather than using kind of like large language models
For
um,
everything.
for everything, yes, maybe the real value actually lays into those kind of like highly efficient kind of like language models that you can fine tune for a specific kind of like from
Right.
like using like clean specific kind of like domain data sets. That they are faster, they're more cost effective, and like then it's better, right? Win-win. Better for production as well.
Yeah.
I think the other aspect, and I think this is an aspect that is usually overlooked, and it's not like it's a bit unsexy and maybe boring, but it's about like the kind of like governance, like rigorous like evaluation and like testing frameworks and so on. I think there is there is kind of like the tendency maybe of like, oh yeah, let's put an agent to everything, and they don't think about and then people don't think about like the implications of using those agents with maybe enterprise data, or like or even like personal data. It's really important to keep an eye on that. So I think I think in the future might be where people actually need to focus more, because actually we haven't take care of this like right now.
Judith, it's been an absolute pleasure talking to you. Thank you ever so much for joining us today. Really enjoyed that.
Yeah, thanks for having me. Thank you, Jeremy. I really enjoy it as well.
Thank you for listening to this episode of Inside the Algorithm. If today's conversation gave you something to think about, make sure you subscribe so you never miss a breakthrough, and share it with someone who'd appreciate the thinking. If you're a data and AI leader looking to build deep technical capability across your organization, Datasparq is here to help. You can reach us on LinkedIn or at cambridgespark.com. And if you want to explore AI from the leadership and strategy perspective, check out our flagship show, Data and AI Mastery, with Dr. Raul Gabriel Irma. Until next time, stay curious, stay rigorous, and stay ahead of the algorithm.